Hello my dear wonderful genius students, I welcome all of you to my YouTube channel. This is lecture number 26 on complex analysis and it is the continuation of the last video. Students, in this video I am going to teach you how to expand a function f of z about a singular point via Laurent series. Students, to expand a function f of z about a singular point z equal to a, we have to follow 4 steps. In step number 1, we have to put z minus a is equal to u. In step number 2, we have to replace z by u plus a and then write this function f of z in terms of u only. Next, in step number 3, depending on the nature of this function, we have to expand this function. This function can be a sine function, cosine function, exponential function, or simply a partial fraction. If it is partial fraction, then we need to expand this function via binomial theorem. Next, in the last step, we have to replace u by z minus a and then write the expansion as a power of z minus a only. Okay? Now, let us solve 2 numerical problems to understand this theory part. Problem number 1. The problem number 1 says we have to expand this function about z equal to 2 via Laurent series. Students, here we have seen that z equal to 2 is a singular point, because if we put z equal to 2 here, then this function becomes infinite. Again, since we need to expand this function about z equal to 2, so therefore the expansion should contain the powers of z minus 2 only. Now let us solve. Here z equal to 2 is a singular point. Now put z minus 2 is equal to u. Next, let us replace z by u plus 2. If we replace z by u plus 2, then this function becomes f of u is equal to u plus 2 divided by u plus 1 into u. Now, let us simplify this term. So, after simplification, we will get u plus 2 divided by u into 1 plus u whole to the power minus 1. So, we can write f of u is equal to 1 plus 2 by u into 1 plus u whole to the power minus 1. Next, let us apply binomial theorem to expand this term. So, after applying binomial theorem, we will get 1 plus 2 by u into 1 minus u plus u square minus u cube plus u to the power 4 minus dot dot dot. Next, let us simplify by multiplying 1 with this term and 2 by u with this term. So, finally, we will get 1 minus u plus u square minus u cube plus u to the power 4 minus dot 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 plus 2 by u minus 2 plus twice u minus twice u square plus twice u cube minus twice u to the power 4 plus dot dot dot. Next, let us add same power terms. So, finally, we will get 2 by u. If we add 1 and minus 2, we will get minus 1. Again, if we add this term and this term, we will get plus u. Again, if we add this term and this term, we will get minus u square. Again, if we add this term and this term, we will get plus u cube. Finally, after adding this term and this term, we will get minus u to the power 4 plus dot dot dot. In the last step, we have to replace u by z minus 2. So finally, we will get f of z is equal to 2 by z minus 2 minus 1 plus z minus 2 minus z minus 2 whole square plus z minus 2 whole cube minus dot dot dot, which is the required expansion. Which is the required expansion. Okay. Now let us solve problem number 2. According to problem number 2, we have to expand this function f of z about z equal to 1 via Laurent series. Students, again we have seen that z equal to 1 is a singular point, because if we put z equal to 1 here, then this function f of z becomes infinite. Again, since we need to expand this function f of z about z equal to 1, so therefore the expansion should contain the powers of z minus 1 only. Now let us solve. Here z equal to 1 is a singular point. Now put z minus 1 equal to u. In the next step, we have to replace z by u plus 1. If we replace z by u plus 1, then this function will become f of u is equal to e to the power u plus 1 divided by u square. In the next step, we have to rearrange this exponential term so that we will get a series as a power of z minus 1 only. So this term can be written as e into e to the power u divided by u square. So finally, we can write f of u is equal to e by u square into, we know e to the power u is equal to 1 plus u plus u square divided by 2 factorial plus u cube divided by 3 factorial plus dot dot dot. Now let us multiply this term with 1 by u square. So finally, we will get e into 1 by u square plus 1 by u plus 1 by 2 factorial plus 1 by 3 factorial into u plus dot dot dot. Finally, let us replace u by z minus 1. So finally, we will get f of z is equal to e into 1 by z minus 1 whole square plus 1 by z minus 1 plus 1 by 2 factorial plus 1 by 3 factorial into z minus 1 plus dot dot dot, which is the required expansion. Which is the required expansion. This is all about today's video, and with that I have completed the contents of module number 3. In my next video, I will start the contents of module number 4. Okay?